Am I on? Okay, cool. Hey guys, what's up? So the basic idea for mine is it's a binary for verifying Bitcoin blocks. So FBBVB. So the name is not very good. It's very descriptive, but here. So the problem. What's the problem today? Problem today is that not many people are validating. How many people run nodes here? Okay, people here validate. That's not a problem for people here. So it's not for you guys, but for the everyday user of Bitcoin, they're not really running nodes. They're not connecting to their nodes with their wallets. And what this means is that you're trusting a third party. So what we've essentially done in about 10 years of Bitcoin is we put trust back in trustless. And this is not good. This is not good for Bitcoin. This is not good for our sovereignty. And so what I really wanted to do is I really wanted to make this simple thing that other developers can take and use so that they can have block validation in their software. So what I did is I made a single binary, and what this does is it does stateless validation. How does it do this stateless validation, you say? So it does this by combining these two projects. One project is called UTXO. What UTXO does is it summarizes the UTXO set into a bunch of Merkle trees. And with this, you can have a really, really small state. And so what this state is what will be passing into the binary. And the libBitcoin kernel project, what that does is it allows us to use Bitcoin Core's consensus code outside of Bitcoin Core to build these other sort of consensus implementations. So where can we use these binaries? So this is sort of where I see this binary fitting in. I see it fitting in like hardware and software wallets. We talked about this a lot in the UTXO project. We really want this in like wireless routers. This past week, I had this really, really fun idea with BitAx, and it was that you could somehow fit in a full node onto the BitAx board and do get block template calls to that node, and also like web browsers, because why not? It's so small that you could just sort of fit in there. And so in this hackathon, these are the things that I've accomplished. It does most checks now. It does proof of work checks. It does UTXO accumulator checks. This makes sure that the UTXO that you're getting is not just out of random. It also now does transaction script tests as well, script checks as well. And the transaction script checks and proof of work checks, these are all using Bitcoin Core's consensus code. So there's less risk of you being not in consensus alignments with other Bitcoin Core nodes. I really, really like this project, and I don't plan on stopping it after this hackathon. And so what I plan to do is I want to add consensus tests. What I really want to do is I want to put it on ESP32 boards. Hopefully we could put it onto like frostnaps and stuff. And right now the binary isn't as small as it could be, and I think this is because of the libBitcoin consensus kernel. And so I think there's a lot of optimizations to do there as well. So I did realize that the things that I'm saying, there's a good ideas, and I could totally be bullshitting out of my mind right now. And so I just pushed this to GitHub. The code is not very readable, but it should build, and you should be able to test that the binary is actually doing what I'm saying it's doing. Before I finish up, I want to do a shout out to these two guys. They do a lot of work on the libBitcoin kernel. Charlatan for just spearheading it for multiple years, and Zero XLT. His PR, his experimental PR right now on Bitcoin Core was what allowed me to do all these different sort of checks. So as for a little demo before we finish, this is basically how you would use the binary. So the binary is called stump. You would give it, hey, like what network am I on? Am I on mainnet? Am I on signet? And then block height, block, UTXO roots, UTXO proof, and then the UTXO data, which is the what's committed to the UTXO roots. And before I finish up, I have this, yes. So it's a lot of jumble, but if I press enter, Oh, that's not good. If I press enter, you get the roots at the next block. Thank you. That's all I have.
Like, do you have a rough idea how small you think you could get it?
There's a bunch of, for the code right now, I am pulling in OpenSSL just because it was just easier to do. So get rid of OpenSSL code. We get rid of all the other code on Bitcoin Core. And if we do that, I want to get it small, so the Utrecht code is small. The other Bitcoin code is big, and so we'll see. But definitely much, much, much less than 1.6 megabytes. Yeah.
You mentioned to eventually be able to run this on an ESP32 board.
Yes.
I guess how much in cost savings would that be for a user compared to, like, let's say, running a full Bitcoin node?
I mean, it depends on like what you define by a full Bitcoin node. But right now, I guess if you buy like an umbrella, it's like $600. I put web browsers in there. So ESP32 boards, I think they're like $10, but it runs on phones, and phones are much better hardware. So that's like everybody has a phone, so that's zero. So that's infinite savings, because you already have a phone.
Great job, functional Bitcoin block validation binary.
Thank you.